Who am I? You know, what's up with my hair? Why is there a bob-omb up there? So I was in tech for a long time. I graduated in the Stone Age from Columbia, degree in computer science. And from there, I worked at various startups, including a place where I was the CTO and a lawyer looked me in the face and told me I had phantom equity, and a CEO got fired for embezzling an $800 ad revenue check. So really good stuff. I also was an early employee at VaynerMedia. I was the first engineer. They now have like thousands of employees. I built a lot of websites and Facebook apps and this kind of thing. Then I landed at GroupMe. I was a software engineer and a web lead. I met a lot of my best friends there. And then Microsoft acquired us, made me use Outlook. So I left, I moved to LA. I joined a company called Splice. I was employee number 1 and built the website from scratch. And I also managed the engineering team, built out the team there, used that management experience and moved over to Tinder. As an engineering manager at Tinder, I had a team of 6, and I, excuse me, sorry. I had a team of 6 at Tinder, reported to the CTO, and after a little while there, I quit my job and moved to Portugal with a member of my team who's a surfer who lived in a van. We moved to Portugal because the cost of living is low, the internet is fast, and the surf is very good. We started an incubator called Super Serious Company, and we built 12 apps in 12 months. None of them achieved any level of financial or critical success. So I reevaluated what I was doing with my life, what kind of traveled around the world, lived in Japan for a couple months. And it was while I was there that I sort of realized, as I was looking out over the Nintendo corporate offices, that I wanted to make art, and more specifically, that the form of art that had most meaningfully impacted me was games, and I wanted to make games. And so we end up about a year later, joined a team making a game called King of the Hat. There's 4 of us. We're like fully independent, and this is our game. Please buy it when it comes out. It's hopefully next year at some point. So that's me. I'm an indie game developer now. I worked in tech for 15 years. I built like 1 million websites. I've done a lot of stuff on the native mobile front end. So let's dive into the conversation about performance. Like, why do we care about front end performance? And this is a question that you should always be asking yourself in engineering. I find that in this industry, there's just a lot of dogmatic opinions that go around, and people saying you have to do this, you have to do this. And you should really always be asking yourself, why do I actually care about doing this thing? And the answer to this is a little tricky. It turns out that actually sometimes we don't care. So software, much like a human being, I would argue, has a hierarchy of needs. And it's debatable what goes where, but this is around where I would put mine. So looking at the bottom of the pyramid, the software has to work, right? No one cares how fast you're going to be able to render your 500 page, right? No one cares how springy the animation is on the alert window that says something went wrong. So a lot of software development, especially early software development, is just getting the thing to work, right? You're spending a lot of time on this side of it. If you have like critical bugs in your application, it's probably not the time to focus on performance. That said, you do want to be thinking about performance from the beginning, but you don't want to be spending your time optimizing before you know that the software fundamentally works. And similarly, you want to know that there's some value to the software, right? Like you want to know, if you're building a company, you want to know that it has market fit. And I'm definitely not here trying to throw shade at anyone who's building something that has already been built or might not seem that valuable at all. If you have any sort of imposter syndrome about that, don't worry, I'm not talking about you here. If you're gaining value from learning in building something that has value because you have value, I'm more thinking about I see a lot of companies that don't answer this fundamental question of, does our software have market fit, before they start optimizing everything. And then above that is kind of like, information architecture. Does it look good? Is it fast? There's a lot of stuff in this sort of realm, and this is where performance comes in. It's when you're really optimizing the experience and trying to make the best possible experience that you can for the end user. And then self-actualization is, software theoretically you can dismantle capitalism. I haven't been able to do it yet, but see how it goes. So we're gonna do this now. Let me just drop this link in the chat real quick. I see. Okay, whoops. Sorry, I swear I know how to use Zoom. How do I unmute all? Let's see. Did that work? Anyone want to chat me and let me know if you've been able? Okay, cool. And then let me see, because I would love to get people to ask questions. Maybe if I make, what if I make you the host? Maybe I'll have to unmute myself. Can anyone unmute themselves, or say in the chat that you can't unmute yourself?
Hey, Neil, it's Dana. I was able to unmute.
Okay. Yeah, it looks like the participants are having some trouble with that.
Typically in the bottom right, there's a settings tab. And if you scroll down on it, you can give participants permission to unmute themselves.
Bottom right. So I think I made you a host. If you want to, let's see. Yes. Maybe. Sorry, this is hilarious. No. No. People still can't unmute, huh? Okay. You said the bottom right. Maybe it's a different UI because I'm screen sharing, possibly.
Yeah, I think I just gave everyone permission to unmute themselves. Can you do it now?
Yep.
Yay.
Okay, amazing.
We're in.
Hooray. Okay, cool. This will actually factor into the talk later because, whenever things take a little while, people start questioning what they're doing, and you lose trust. So you've seen it firsthand, Now you're like, does this person really know what they're talking about with performance if they can't run a Zoom meeting? So cool. So everyone can unmute now. Great. And then the link should be in the chat. So can anyone volunteer? Do you have any idea what your response time is? Like this, sorry, I'm gonna go through this disable process real quick. I think I did this on a different, yeah. Continue. Okay, so this is a reaction time test. I don't know if anyone's seen one of these before. But can anyone volunteer an answer to how fast, without scrolling around this page too much, how fast you would expect your reaction time to be?
400 milliseconds.
400 milliseconds. Yeah, that's a good guess. So let's do this test a couple times because I find it's really good to actually feel it. So you're going to click this. You're going to wait for green. Just have your hand on the mouse. As soon as it goes green, you're going to click. Yeah. So mine is quite slow today, it would appear. You can do it a couple times once you get used to the UI and really try to get it like instant, right? As close to instant as you can get it. And I found this to be very eye-opening. Yeah, I'm a lot slower than I was before the demo, which is interesting because what's happening during that time, right? This reaction time is on sort of a normal distribution amongst all humans. You know, it varies within a range somewhere between, 100 to maybe 400, 500 milliseconds. So that was a great guess. Was it Ryan who guessed that? So the interesting question to me is what's happening here, right? What happens for that 100 milliseconds before you can react to anything? And the answer is that's where your like human processing is kicking into effect, right? It takes some number of milliseconds for images to hit your retina, for your brain to flip them around, for the signals to be sent to all the neurons and everything, and for your like human hardware to process things, right? This is like more than a theoretical limit. This is like a physical limit of how fast humans can respond to things. And like, to me, this is the jumping off point to what's fascinating about front-end performance is that there's limits to perception. So, and these are just kind of hard-coded in us as animals. So nice, 297, nice, Malcolm. I don't appreciate you posting that you beat me, but I'm proud of you. Good job, 297, pretty good. So 60. So we're going to look at some key values, and this comes from this is from web.dev web.dev/rails, I think. Nope, rail. The link is in the bottom. Yeah. So this is the response animation idle load. People have different sensitivities to different types of latency. And so going back here, so 16 milliseconds, this is sort of the benchmark for anything video related, anything frame rate related, definitely video games, animation, 16.6 repeating, of course. Milliseconds is 60 frames per second. And there's a reason that that is sort of the, one of the key benchmarks for rendering video is that somehow that number tracks roughly to what the brain is experiencing in real life, right? In real life, it seems like you're, like watching a movie of your surroundings, but actually your brain is just processing images and stitching them together to make a coherent story about what you're seeing. So if you're dealing with stuff like animations, you're going to want to be very mindful of this 16 millisecond mark. Then when you're talking about a response to user input, anything below 100 milliseconds, at least on the web, is going to feel instant to the user. But anything above that is going to feel, they're going to feel a delay. And so this is like a key benchmark, again, for like responding to specifically to input, because if a user is watching something happen and it takes a little, a little loading spinner and then it eventually loads, that's a different sensitivity than if you press something. You really want immediate feedback, like feedback as fast as you can. And we've seen in game development that, there's a huge difference between the game feel, it's called game feel, of like moving a character around with a 3 or 4 frame delay, which will be around 100 milliseconds, versus a 1 frame delay to your actual input. So then around 1 second, you have the immersion break. So basically, it varies per person. This could be around 500, maybe 700, maybe 800 milliseconds. But this is a really key point. where once things start to take around a second, your brain and your, just your physiology has enough time to do enough cycles to say, should I be paying attention to something else instead? So when it comes to directing the user attention, this is definitely a key milestone. Like, going back to the pyramid, if you have, consistently like over 1 second load times on your pages, you're going to start to see like some real, you're going to start to see some real drop-offs to the level of immersion. Sorry about this. Okay. And then around 10 seconds is where you start hitting the just contemplation of your own mortality, the people getting hungry, basically the like full abandonment point. And just to kind of demo some of these things, we're just going to look at what these response times look like in real life, right? So this is, let's see, drop this in. So this is 16 milliseconds. It appears to be completely instant to us. We don't notice the difference. And it's worth noting that if you're doing backend optimization, if you're doing machine-to-machine optimization, 16 milliseconds is like a lifetime in some applications, depending on what you're doing. A machine definitely notices the difference. And the difference is physically there, but we don't notice. We literally can't tell the difference. Here, okay, seems the same. Like, I don't know about you guys, but that seems pretty much the same as 16. But it's hugely different. It's almost 10 times more. We can even make it 10 times more. And you'll see, okay, there's a tiny delay now. But this, again, is just about the limits of perception here. And now let's look at 1 second. Yeah. So you see how something different happens when that's going on. There's enough of a delay for you to have a thought as to, is this working? Is this going to work? And then it goes, okay, it works. Okay, we're going to move on. But if that keeps happening in your experience, that's going to break immersion. And now let's look at 10 seconds. Yeah, that was really uncomfortable, right? That was awkward. You were waiting for something to happen. There's enough time for your brain to not only wonder if things are going to work, but also start deciding things aren't going to work, or I have something better to be doing right now. And maybe that's something you want in your experience at some point. It depends what you're building, right? Maybe you want the user to pause and think about things for a second. And so this kind of benchmark is useful for that. So why are we talking about these kind of limits of perception? Well, we're going to look at the difference between back-end and front-end performance and optimization. So back-end, you're talking about a huge number of clients potentially, like, a very popular app is going to have tens of thousands of requests per second. And you're trying to solve the problem of, through one entry point, how can we kind of max out what an individual computer can do and what a network of computers can do in responding to other computers. So your constraints are very much machine-based, whereas the front end, you have one client, one computer per user. And yeah, you have to deal with network latency for sure as a big part of what you're going to be optimizing. But ultimately, you're not really dealing with the physical limitations of the hardware, right? Most computers are going to have enough kind of CPU and RAM to do a lot of the, you're not stretching those to their limits. But what you are dealing with are the limits of human perception. There's only one diagram here that includes any entities that have evolved from apes, right? So you ultimately, I think, even though at the beginning, back-end performance and front-end optimization seem very similar and you're doing a lot of the same tasks, I think at a high level, back-end is the study of machines. If you're going really deep, you're going into, I had a friend who helped build the AWS S3 service, and all he talked about was stuff like disk seeks and other hardware terms that I don't know because I never went that deep on that side of it. But you're really dealing with the physical limitations of the machine, and you're understanding at a very deep level how machines work and how they work together. And on front end, you're really delving into the human psyche. What feels slow is different than what actually is slow. And there's a bunch of fascinating things that you'll find as you delve into the field about sort of psychology and about neurology, I guess, of just what we are looking for in an immersive experience. And in terms of kind of the method or what you're trying to achieve, I'd say backend is more scientific, right? There's, again, hard numbers. There's like everything just comes down to a really hard scientific number, whereas front end, it's kind of closer to magic. And I don't mean magic as in you don't understand what's happening. There's definitely a lot of measuring, and there's a lot of optimization and a lot of science that goes into the front end side. But at the end of the day, what you're doing is similar to magic in that you are directing a person's attention. Like, it's the study of what a person pays attention to and what they don't pay attention to. And you're putting as much of the things that you don't want them to pay attention to, like loading times and this kind of thing, into the area where they don't see. And you're trying to, basically craft a narrative for them of what you want them to see. So, and it can feel like magic when things load really fast. So I swear this is related, but this is on the tip of like magic and how you can use psychology and these at this millisecond level. So I don't know how many of y'all are familiar with animation and with this tactic that's called a smear, but you can see it in basically any type of animation. We're gonna watch this. We're gonna watch this little clip real quick, and then we're gonna look at frame by frame data. So this to your brain, we're gonna watch it again. It happens very fast. So I don't know about you, but to me, this looks like two characters just like zipped into the scene. They just came in really fast. What's actually happening on a frame by frame basis. Sorry, just gonna check this to see. Okay, great. What's actually happening on a frame by frame basis is things that you would never see in the physical world, right? This, what is that? This, okay, now it's back to normal, right? But these frames you would never guess are in the animation, because your brain takes these frames and goes, I don't exactly understand what I just saw, but I think something just moved really, really fast. And it tells you something just moved fast into that spot. It's just a blur, right? But this is a technique of animators to do this. They do this in SpongeBob also, right? And here it's like a little more comical. They have this anticipation, which tells your brain, get ready, there's about to be some movement, pay attention to the left side of your screen. And then it goes, bam, right? This is, someone had to hand draw this, but animation at this level is really playing with some of these holes in, or not holes, but like some of these limitations of human psychology and and I think a lot of front end performance gets into this kind of area, which I personally love and find fascinating, because in measuring front end performance and its effect on yourself and on your users and your user testing, you're also just understanding more about how humans perceive their reality in general. So getting back to the question of why do we care about performance? Okay, so we care because ultimately it's human and we care about studying humans. But yeah, there's other ways to do it for sure. There's other ways to study humans. And so I guess let's just talk about the normal reason that's given for why we care, which is the money, right? So there have been countless studies that show that latency correlates directly with revenue. You can go to this WPO stats thing and get all of these, reports of how increasing performance has led to making more money, better revenue, better business stuff, all that kind of stuff. But I think that points to a deeper truth, which is that optimizing at the millisecond level creates better experiences for people. So whether you care about using technology or software to make money, or whether you're trying to make a certain type of experience happen, whether it's some combination of both art and business, right? It all comes down to this, if you all know what that is, which is engagement. Okay. This is like fundamentally what we're trying to do with our experiences, is to create engaging experiences that that keep the user's attention, right? Without their attention, you have nothing. So we're going to move on to the interactive part of this, but that is my spiel about front-end performance and why it matters and why you should care. And so before we move on, I'm going to give some time for questions, and whether y'all have them or not, we're just going to put a little timer on here for 20 seconds. It might get a little awkward, but when people are giving talks, I always feel like I don't have enough time to actually formulate a question. So we're going to do this. Feel free to unmute yourself or say in the chat that you cannot do that. Okay. All right, 20 seconds, no questions. That's a good sign, I guess. Okay, so who's ready for the interactive piece? Does anyone want to unmute and say that they are ready for the interactive piece?
I am ready.
Okay, hell yeah. So performance, how do we do that? So this, you guys should just memorize this. This is like pretty much this is the whole game. This is what you're going to do at every level, no matter what you're doing that's performance related. This is what you're doing. You start by measuring what the performance actually is, and then you make a change, and then you measure again, and you just repeat this process. Right? This is it. This is the whole thing. And as you develop your skill set, your measuring is going to become more sophisticated. You're going to know what to measure. You're going to get better at having the tools to measure things more accurately. You're going to get deeper into the process of measurement, and you're also going to gain experience in terms of what your intuition as to what you might need to change. You're going to gain intuition as to you're going to gain experience as to what you can change. So here today, we're just going to do some kind of like really basic fundamentals around some of the fundamental measuring tools and some of the fundamental types of changes that you might be making. So if everyone can clone down this, I will throw this in the chat also. This little repo. Come on, chat. Why? Okay. I feel like such a boomer right now. Oh, yeah, I see. Okay, well, yeah, thank you, Kaylee. Awesome. So if people can just let me know when they have that cloned down, we're gonna, I'll give you guys like a minute to get that all set up. And give everyone an opportunity to ask more questions. Cloned, great, thank you, Wolf. Yeah, if people can just confirm in the chat that they have it cloned, great. Thank you, Em, Jordis. Good job, everyone. Brian, Donbay. Done. Nice. Okay, done. Excellent. Y'all are pretty fast at cloning. That's pretty good. Okay. Do I have it cloned on this? I think I do. Yeah, I do. All right, cool. So we're going to start with how do you measure? And so we're going to start with like the real kind of Swiss Army knife, lowest level from a JavaScript perspective. Y'all are all familiar with console.log, I'm sure. We also have console.time. That's why I pay you the big bucks. Yeah, hell yeah. That's what people want. When I was interviewing people at Tinder, you know, when I was doing like 4 interviews a day, I was like, can you clone 30 repos in the next 10 minutes? So this was let's go back. So let's just look at this console.time command real quick, and then we're going to jump into the example and see how we might use it. So you hit it once and it's going to start a stopwatch. You can then log various things that you might have. You know, I just hit some checkpoint. Right, and this says, okay, that happened in 17 seconds, and then you can time end it, and that'll print out the total time that that timer has been running for. So this is really your your lowest level method of optimization, and I'm going to show you all what we are going to be optimizing, which is we're going to start with slowjs.html. So this looks pretty simple. Just HTML body. There's a script in here, and there's an h1 tag that says hello world. So you would expect that it would just, print hello world pretty fast to the screen. And what we can do is we can go open slowjs.html, and you will see there's a spinner for a while. There's nothing on the screen. We're starting to hit a pretty awkward point, starting to contemplate the old mortality. Yeah, still nothing. Wondering if this thing even works. Yeah, responsive. We can exit the page. Okay, there we go. Hello world. Well, that's unacceptable from a performance standpoint, wouldn't you agree? So let's take a look at what the culprit might be here. Well, we know it's probably that. So if we reload now, yeah, that loads instantly. So we're going to go into this slow.js file. And here we have a bunch of for loops. So a bit of a contrived example, of course, but you can just replace these with any sort of kind of black box functions that y'all might be running on your, on your more complicated web app, on your React app, right? There's going to be certain functions that might have performance costs. And our first task is, we open this thing up and it's like, well, we're doing, these, whatever it is, 6 blocks, 7 blocks of things. How do you think we can answer the question of which of these is going to be at fault for this performance slowdown? Or does anyone have any guesses right off the bat as to what might be our source? Square root, good guess. Good guess. So here's a way that we can check that, right? Here's a way that we can use what we just learned for measurement. So we can say, this is the beginning of the square root code. And here we're going to time end, and we're just going to return right after that. So now we can go back to the browser, pop open the old console. Oops. Oh yeah, no top level returns, huh? Well, we're just going to have to wait through. For now, I'm just going to comment these out. And we're going to make sure that we still have the slow JS. Yeah, we go back. Okay, square root, 164 milliseconds. Probably not the biggest culprit. Query selector on all spans. Great idea. Let's check that as well. So now we're going to throw in console.time query, or sorry, this one is on the creation of the spans. Query selector all. We're going to time end it. We're going to go back. We're going to load. It's going to take a while, but we got some output here, right? So as you're, one of the hardest things about doing performance optimization is that you're usually doing it on something that's very slow. So your iteration time is going to be very slow. This comes into play a lot with like Webpack builds and that kind of thing. Like once you get to the point where your build is too slow, you probably have like a ton of stuff going on and it's just harder and harder to optimize the deeper you get. So it looks like query selector all, great guess. This is a full 1.7 seconds. And so now we're starting to see some of these values, but we kind of want to know what's happening, what the overall time is, so that we can figure out how much of this, what percentage of our overall wait time. We know it's long, but we want to be able to measure as much as we can here. And so what we're going to do now is use our console.timelog to really just see, we're going to manually instrument this whole thing. So we're going to say, everything. And we're just going to throw a little time log after each block, right? So this is multiplication, or we can just say I times I. This is square root. We already have the measurement, but just for the sake of completeness, we're going to want to log for all of these. Math.random date. And we have create span. And we're going to time end everything. Let me know if I'm moving too fast or too slow. Is this a decent speed for people? Because I can't see y'all's screens, so I don't want to move too fast. Anyone want to give me a yes, no? Okay, we got a thumbs up. I will take one thumbs up. Great. Good speed. Perfect. Thank you. Okay, so we reload. And now we're getting little outputs from everything, right? So we see square root 358, multiplication not that far behind, square root, an order of magnitude, like it's a little more complex, but it's kind of linearly more complex. New date 17 seconds. Create span. So one thing about the time logs is that, oh yeah, sorry, I was reading this wrong, my bad. Multiplication actually took 195, and then square root is 358 minus 195. So the time logs are going to just say how much time is going in the timer, if that makes sense, the timer that we set at the beginning. So here we can see math.random is about 9 seconds after square root. So that's pretty significant, or sorry, 900 milliseconds. After square root, so bad, but not our main issue. And here we have our 17 seconds of creating new dates. And then here, creating the spans is really minimal, maybe about 20 milliseconds. And then everything all together, the query selector all, which we have the separate measurement for, is about a second. And so we've discovered through this that our real issue is here, creating dates. Yeah, dates. Hi, Bennett. I know Bennett in real life. I swear, I have friends. Yeah, you wouldn't expect it to be dates, but keep in mind this a lot number is 100 million. Yeah, is 100 million. So if you're creating 100 million dates, probably something's going wrong. You don't want to be doing that. But these kind of surprises happen all the time when you're doing performance optimization. You're going to look at, this is like very common for what front-end performance optimization looks like, is you look at a file, you go, you know what, it's got to be this, or you know what, this is really sketchy. I think it's this. And that's why you have to measure, because more often than not, it's something totally innocuous seeming that you would never think is going to be your culprit. This is like just par for the course for optimization. And this is why, going back to our little slides here, just gonna really try to emphasize this. This is why you do this process, right? You measure, you make a change, you measure again. The most important part of optimization is measurement, really, truly. So here's our console.time logs. Does anyone have any questions about that before we move on to the next thing? Okay. If you have questions, also feel free to ask at any time. So let's get a little more high tech. So we have tools that ship with the browser that are going to really help us inspect what's going on here. You have your network tab, of course, which will show you, which is not very relevant in this case, but you also have this performance tab. So let's get in this performance tab, and just for the sake of, since now, actually we should leave this in. So in the performance tab, you have this Command-Shift-E to reload the page and record the entire page reload. And this is generally what you're going to want to be doing when you're analyzing performance. And this is going to give you a lot more information than your time logs. So let's go Command-Shift-E. In here, yeah, here we go. So it's loading, it's loading, it's loading. We're profiling. This is going to take about 17 seconds for sure. Also, something worth pointing out is that it may be surprising to some of you that a script tag would actually just slow down the rendering of the overall page. Like you would think that it would just render the HTML and then start evaluating the scripts. But scripts are actually blocking by default. So something to keep in mind that we'll talk about a little later when we talk about deferring is that this, your script evaluation, if it's in the head or if it's in the top of the body, is going to be processed before any of the DOM elements get rendered. So let's look at what we got back from our performance. The first thing you're going to want to look at is this pie chart. So where are the issues coming from? And if you're having DOM issues or image issues or anything like that, you'll see more stuff in kind of the rendering and painting area. I would guess the reason that we're seeing 1.5 seconds on rendering is because we created all those span tags. But our main culprit is scripting, which tracks with what we saw in the console.time, right? And from here, you can actually go in. You have this call tree that's sorted by the total amount of time that things took. And you can go in, and we actually didn't need to necessarily add all of those console.times, but you can see here that those new dates are actually hidden. So while we are getting this query selector all, and we know that that is a problem, and that's a clue, a hint that we have as to what's actually going wrong, we still have this unaccounted for kind of 17 seconds, which we now know based on our console.time that that is coming from the new date. So this is usually the place where you would start, is you would go into this performance tab. You have all these events as to what was running when. Here we have, our evaluate script, and then this is going to have all of your, it really breaks it down. This is a lot more useful when you have named functions, of course. But this tab, I mean, you can spend a long time in here looking at, it gives you all the frames, which is going to be less interesting for our not super complicated app. But if you go to something, these frames are like nothing, 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 hello world, right? But this becomes a lot more interesting when you're looking at progressive optimization and enhancement. So this is the Chrome Web Inspector, and then let's just go back here. So that is the Performance tab. You also have your, like I mentioned, your Network tab, which is going to capture any of the, this is going to capture any of the like images and, you know, when you're working on network optimization, you know, typically on the web front end, your issues are going to be either network related, image related, or JavaScript related. And so the Web Inspector is basically your best friend when it comes to debugging any of those network performance. And then the next thing we're going to talk about, which is Lighthouse. So I don't know if y'all have seen Lighthouse be demoed before, but Lighthouse is going to analyze, it's an open source project that's going to analyze everything about a web page and is going to return like an overall score along with some recommendations for what you can do, kind of best practices from around the web. And so let's take a look at two kind of real sites in order to look at what Lighthouse is going to give us back. So this to me is like pretty much the gold standard in web performance. And it actually, it's interesting because it shows you some trade-offs, right? This is what the code looks like. If you checked in code that looked like this, you'd probably get dinged pretty hard for what is this doing? Like this is totally unreadable. And if you're really trying to juice max performance out, this is what your code is going to look like, right? And this is like even more, this is even more optimized than like your typical minification process for like shipping to production. So let's look at the google.com homepage, and we're going to go to this Lighthouse tab in the Chrome Web Inspector, and we're going to hit this generate report. And so this is going to run through on a variety of mobile devices and just a ton of like accessibility checks, SEO checks. You can turn all this stuff on or off, but the thing you definitely want on is performance. And this will be, that's hilarious. That is not what I expected and not what I was getting earlier, but this might actually have to do, now that I'm thinking about it, with an extension that I added to not have slides scroll. This normally gets around like an 80, something like that. And this, these are some of the key metrics you want to think about for your front end things, which is first contentful paint. So that means the first time something was rendered to the screen that someone could see. And then you have your time to interactive. I'm actually wondering, I'm just going to check real quick whether we're using the swap for some reason, whether Docker. Yeah, we are using the swap. Okay. Stand by. So a lot of these, yeah, so actually this is a great time to talk about degraded performance because of, you know, a lot of you are going to be testing on kind of newer hardware, and there's a couple moves that you are going to want to be able to do in order to simulate what you know, your users around the world are seeing. And so one thing you can do actually is you can look at, you can basically peg your RAM so that you are using the swap. And there's various tools that allow you to do that. You can also, there's this thing, the network link conditioner. You can just Google network link conditioner. And what this is going to do, I'm not going to turn it on because it's going to mess up our Zoom call. But what this is going to do is just system wide, it's going to throttle your network so that you can see how your site loads for someone who's on a non kind of broadband fast internet connection network. This is like a key part of performance and optimization. Like again, it's like you want to get everything working, and then you want the kind of base level performance for your machine and your internet connection. And then you want to start looking at different levels of, machine and internet connection stuff. So if someone is running low on RAM and they load google.com, it would appear as like a 66. I'm sure you guys are seeing different values for google.com. I can't wait to see what my next example does on Lighthouse, actually. So let's go to ihatejira.atlassian.net, and we're going to go here, Lighthouse, and let's generate a report on just some settings page. That's just a web form that should be rendered in, 500 milliseconds max. So we have, again, I have my my RAM kind of pegged, and here it's loading up all these different versions of it. We're going to see how this does. Yeah. What's funny is that when my RAM wasn't pegged by Google Chrome, this was like around a 10. And so if you've ever wondered why you kind of hate being in Jira, it's because of this, 100%. So these are just some examples of real life production software and what those kind of things look like. And you can take this measurement tool and put it towards anything. So as you start to become more in touch with your own experience as a consumer and what bothers you about performance, you can always use this tool to get a sense of what's happening out there on the web. And of course, for your own applications, you have these, you have these metrics, and you have these what are they called? Recommendations. Yeah, for anything that you are not getting good scores on, you'll get actual, actionable automated stuff to improve your experience. And so going back to our little presentation, so that's Lighthouse. And then, so in terms of what to change, so this is my favorite thing to do currently as an engineer, is delete code. You always want to, the first question you want to ask yourself when something is not performant is, can we delete it? Can we just delete it? Does it have to be on this page? Does it have to be here at all? This is, a question that you should always be asking yourself. Is it possible to fix this performance issue by just deleting the feature? If that is not possible, which it often is not, you can defer it. So we're going to take a look at an example of a way to do that, or two ways to do that. So on this script tag, there's an attribute called async. You throw that attribute on, you go over here to wherever the thing was. You go here, and boom, hello world loads immediately. Even though the spinner's going, sure, the spinner indicates that there's JavaScript that's being processed, but replace hello world with whatever interesting content you need to be showing. And this async tag is just saying, regardless of where this script gets included, just treat it. Oh yeah, there you go. You have this whole, explanation. I don't need to explain it. You got an explanation right there. Another move, if you can't put an async tag on it for whatever reason, just put the script tag after the content being rendered, and boom, same deal. You can see the hello world. It's still spinning and working, but it is, yeah. Sorry about that. Yeah, but so this is another way to defer. And there's many different ways, many different versions of deferring execution, right? You can do a set timeout. These are all possibilities. Now, I was going to show some moves that you can do here, but we are running a little low on time. So if you want, as an exercise, you can uncomment or comment these back in and try to figure out how to support this use case of rendering yo 10,000 times without the major, the hit that you're going to see of appending the children. But I think we should move on to images actually, since that's like a big part of your guys' actual project. So we're going to take a look at slow images.html real quick, 3 minutes. Let's go. Speed run. We are going to hit this. Slow images. This is loading a very, very large image. It's taking a very long time. And this is going to be this is a pretty common problem with front end, is having these images that just take forever to load. And one of the things you're going to want to do is, we're just going to go back here. So caching it is like a pretty important thing. You want to be aware of how the browser treats, there's like specific headers. The reason I'm kind of blazing through a lot of the specifics on this is that you have this site that I'm going to link in the resources, and this is really going to give you a lot of the like in-depth detail about all the moves. It's just everything's a very deep topic, right? So what I'm trying to give everyone here is just an overview of what performance and optimization looks like. And as far as the web is concerned, there's a lot of best practices that are just out there. So if you're seeing, you start here, and if you're seeing in your app that images are your problem, well, you have all of these possibilities to make things better. And yeah, we have 2 minutes. So caching, yeah, very important. Okay, great. We're at the conclusion. So you have measure, change, measure, change. It's an infinite loop. We're engineers, we don't like infinite loops. So you need to have a goal. If you're going into performance optimization, you have to have a goal in mind. And when it comes to setting a goal, again, this web.dev site is going to be your best friend when you're looking at performance. They have this whole long article about how to choose the metrics for your goal. So they have some suggestions: under 5 seconds time to interactive, under 170 kilobytes of resources. These are all based on just like global trends for browser usage. And yeah, so when you're optimizing once your product works and you want to optimize it, the first thing you want to do is measure it, figure out where you're at, and then set a goal using some of these criteria or using your own criteria. And then you're going to want to basically just make moves to make that goal happen. And again, your main strategies are going to be delete, defer, or cache. Okay, cool. Here's some resources. We didn't actually end up getting to this, but you can always just, if you have a static image, there's just online things that'll compress your image a ton. You have Cloudinary, which is a free backend service that you can use, integrate against your backend in order to create thumbnail images and that kind of stuff, which you guys will probably be using for your thing. And then there's another resource below. Oh yeah, Cloudflare, which is just rad. It's free, and that's going to help you with edge delivery with having a free CDN. Okay. Well, okay. What about defer? Nice, nice, nice. Yeah. So it's 4 o'clock. Yeah. So that was my talk. Very perfectly time managed. And do y'all have any questions for me?
Just one question. I'm not part of the Twitch cohort. Is this recording going to be sent out to people that are not part of that cohort?
Hey, Neil, I can jump in and grab that. Yeah, so we will upload it to our YouTube channel, which is pretty small and like basically unlisted. But what I'm going to do is once these talks are over, I'll send out the links of the recordings. So if you're interested in them, you can catch the link there.
Awesome. I appreciate that.
Of course. And Neil, I wanted to ask you as well, are you able to share your slides?
Yeah, totally.
Great. Thank you.
Cool. Anyone else? Okay. Sounds like we're good. Thank you all for listening and staying for the full hour. I hope this was useful. I hope it got you interested in front-end performance and optimization. Hey, there you go. Yeah, thank you. Oh yeah. As you can tell, I very much thrive on interaction and feedback. Oh yeah, oh, this is good. This is good stuff. This is really good. Okay, thanks. Yeah, this made my day. I had a great time giving this talk, and yeah, I wish everyone the best of luck with all of your projects and with all of your future endeavors in the world of software engineering. It's terrible. You're going to hate it, but it's pretty fun. Have a great day, everyone. And I'm going to stop sharing my screen here. And yeah, I think that's it.
Thanks so much, Neil. Thanks, everyone.
Bye.
Bye-bye.
Thanks. Bye.